everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire, and today we've got Rawan, who has just completed the course ROS 2 Basics with Python. So she'll be giving us a presentation on a project and explaining the details of how she managed to do a project. So first of all, as usual, we'll see a demonstration on the real robot, and then we'll get to the details later. Afterwards, we'll get to ask you a couple of questions as well. All right, Rawan, whenever you're
Okay.
ready.
Okay, thank you. Hello, my name is Rawan. And this project, the robot is required to, first of all, find the wall, the nearest wall,
Mm-hmm.
align next to the wall, and then it would complete the whole lap around the lap. So here I'm gonna run it and we'll check it works properly. So now the service is being called successfully. Now it's rotating to find the nearest wall. It found the nearest wall. Now it's aligning. So the service is working properly. It aligned. Now it's starting to follow the wall, which means also the main code is working. And as you can see here, it started recording the positions, which means the action server is also working properly.
Mm-hmm.
There's here you can see that it constantly measures the distance between the robot and the wall, and if it's too close, then it just steers to the left. If it's too far, it steers a bit to the right.
Mm-hmm.
I hope it does not collide with this. It should not,
All right.
but uh, oops. Yeah, okay. Okay.
All right.
Did
It hit
uh
the wall a little
okay.
bit. Can you? Yeah.
Can I restart it? Because like in 10 runs, one out of the 10 runs, this happens,
Mm-hmm.
but it should be fine if I run it again. Let me just, I will put it back into, also my internet is pretty bad. I apologize for that. Sorry. Okay, this should be fine. Okay, I got.
All right. So it's still finding the wall.
Yeah, the service is still on. Okay, now I think the laser is not. Can I just uh, okay, that's kind of because sometimes, like one time when I tried it, the
Mm.
issue was the laser scan was not pub
Wasn't publishing.
was not send yeah, it was not publishing
Okay.
properly.
So yeah, then it would be blind. It wouldn't be able to find the wall.
Yeah,
But right now we can see that the scan topic is available.
just um,
Okay. Very good.
okay, but it's sending the same.
Some values. Can you try maybe disconnecting and reconnecting again? Or
Yeah, sure.
you can terminate
Okay.
the script, uh, the obstacle, the wall follower, then try again.
Hmm, okay. Just turn it off and turn it on again. I just tested my program like 30 minutes ago and it was working pretty well.
Yeah.
But hopefully just the lab.
Or at least it completed the first lap, right? We just wanna do a second run to
Yeah.
just confirm. So
No, I have trust in my program. It will work.
that's good.
Okay. Uh, Hopefully 4 minutes is enough for the lab. Yes.
It should be fine.
Yeah, it's not it's not showing. Okay.
All
Okay.
right, there we go.
Yeah. Could it be because of my internet connection?
Mm,
Don't
I don't think so. Um, um, you're gonna have it start from the same place. Okay, that's fine. So
Hmm.
can you try moving it to a different spot? Maybe using the joypad or teleop.
It keeps lagging a lot.
Okay.
Oh. Can you still hear me?
Um, all right, there we go. Hi, Rowan. Can you hear me?
Yeah, I can hear you now.
All right. I was saying, can you try have it start from a different place? So move it to one corner and have it start from there.
Yeah, okay. Um, let's
Okay, I think
okay.
that should be
Yeah, I
good enough.
think this is fine.
Yeah.
Yeah. Okay, I'll just copy paste it.
All right.
Okay. Okay. Yeah, it's okay.
Okay, there we
Okay.
go.
Mhm. Okay, no, it's not working properly.
Yeah, let it finish at least,
Yeah.
or let it go
Okay.
around so we see how it will do.
I don't think it will go back to the same start position, so the lab would not be detected properly.
All right.
Like, yeah,
Yeah, it's fine. I understand that. It's just that we want to see, does it at least avoid the big obstacles, right? Um,
yeah,
so you see that, I think that's it's pretty good so far. There is a little bit of drift, so then it ends up in the wall somehow. But yeah, you can let it go
okay,
for maybe just a couple more seconds.
okay. I wish I recorded the last run before this don't call,
Yeah,
but it's fine.
it wouldn't work exactly the same way. So I don't think you should beat yourself up for that. The environment changes, and normally with real robots, you can
Mm,
never really have it happen in exactly the same way. So anyway, those two were
yeah,
good enough. Can you now take us through your
Okay.
code? What did you do?
Yes,
Um,
of course. So first, I'll start with the main wall follower script.
mm-hmm,
So first, I would import the libraries I would need, like velocity and the service and the actions.
mm-hmm,
So first here, I create a service client. So I call my service server,
mm-hmm.
and um, yeah, here it would wait to call it. It would wait for the server and check service and check for an error. And then here I would call the action client similar to the service.
All right.
And again,
Can you
but here it doesn't check for errors. Sorry, yeah.
all right? Can you move your window slightly to your right? Your code
Wait.
window. You can stay
Sorry.
there. Just move the window. We'll be able to see your code. Okay. Yeah, that's better.
Can you see? Okay.
Okay. Now there's only half of you,
Um.
but yeah. Okay, that's better. You can go on.
Okay. Uh. Okay. So here, I send an empty goal to start,
Mm-hmm.
and then here, this is my main loop for the wall follower.
Mm-hmm.
First, I get the ranges of the laser, and here I would only use the right and the front distance. And I've tried first to get the specific like 270 as mentioned in the instructions,
Mm.
but it didn't work well for me.
Okay.
So I've tried to just divide it by two, as like in the middle, I would consider it as my front um, distance, and the most right ranges are the ones like the first quarter are my right distance.
Okay.
And then here I would, if the front is less than 50, then it would take a turn, so turning left. And then if it's more, so it's too far from the wall,
Mm-hmm.
so it would steer right. And then here, if it's less than two, so it's too close to the wall, so it would steer left. And
Okay.
then here, which is if it's fine, if it's between these two, it would just go forward. And then here I'm publishing the velocity command, and this is just the main for this.
Okay.
Node part.
All
And
right.
then here I'll have my
While you're still on the wall
service.
follower, um,
Yes, sorry.
can you go up a little bit? So you spoke about not being able to do it exactly like what was specified in the script, right? Like so using 270,
Yeah,
right?
yes.
Can you tell me what do you think might be the consequences of your choice of method, right? Where you just split your ranges data right in the middle, right?
It could cause, like here I'm assuming that I would always get 360
Mm-hmm.
ranges.
Mm-hmm.
That might be a bit faulty
Mm-hmm.
because sometimes I might not get 360, but until now, every time I've tested it with this method or the first method would cause more errors than this method.
All right. So you actually proved that your method worked better than the one that was suggested.
Yes, yes.
Okay. Okay. That's good. Okay.
At least for me, I'm not sure if this is the correct way, but for me, this is what worked.
Yeah. I
So
think.
I've decided to go this way.
Yeah. I think it's quite important to figure out what works, right? So I wouldn't say that was bad. I think
Mm,
that's actually good practice to be able to figure out for yourself what works and what doesn't, and not just to take
mm,
everything on face value, right? So that was good.
yeah.
Um, I think
Okay,
you can
thank
go on to the find all saver now.
you. Okay, so now I'm gonna go to my service. So of course we import the necessary libraries, and then here I'm just uh, creating an empty variable. Here, this is just to update the latest scan
Mm-hmm.
array. And then here I'm gonna have, okay, so before I explain this one, first I've tried to get the wall by just reading the ranges of the laser, and I would just go to the index that's the nearest to me, and that almost every time led to the robot just going into the obstacles. So I've thought of a way of basically, instead of reading range by range or like one variable in the array, I would read clusters. So I would take like a segment of the array,
Mm-hmm.
and then I would take the mean of it. So I would find out if those ranges are a flat object,
Mm-hmm. Okay.
which is the wall basically.
Yeah.
And if they're all the nearest to me, then I would go to that, considering that's a wall and it's not just the nearest object, because using just the range like one by one
Mm.
was not sufficient.
All right.
So this is what um,
What happens?
this function does.
What happens when you encounter obstacles that are very thin? For example, you remember the mobile obstacle, the movable obstacles we've got, right? So,
Yeah. Mm.
did you try to think about that? How you could compensate for that using method?
Uh, but this is just for the service. This is just for finding the wall. After
Okay.
finding the wall, it does not work anymore.
All right. All right. So
This is
it
not
was.
used in the wall following logic.
Okay. All right. All right. Okay. So.
Yeah, yeah. So this is the logic for it. It's this is a loop to try to find uh first it takes 40. I've had to like try and error
Mm-hmm.
like 20, 40, 60 readings.
Mm.
So this one would take 40 readings as one segment, and then it would read through, it would create a range or a segment
Mm-hmm.
for this, and it would check if this could be considered a wall or not by taking the mean of it
Mm-hmm.
and seeing if this mean would be considered a flat object.
Okay.
And then it would also and it would measure the distance, and if the distance is the lowest, and for example, if I find two walls, which one is the nearest to me, that would be my wall,
Right. Okay.
basically.
I see.
Yeah. And then here I have basically like an error um, loop to handle the errors. It just here I'm waiting for the laser scan, because the laser scan takes a bit longer to publish. Like you need to wait for it a bit. So
Mm-hmm.
here I am waiting for it, and here I set the rate of the readings, and this is just for waiting for it and checking if it's empty or not.
Mm-hmm.
And then here I would get the front index, the front like the front laser range.
Mm-hmm.
And then okay, and then here I am rotating. After I found the wall, now I have the index of the wall and the distance. So now I am rotating 90 degrees so I can face that wall. And then here I'm just moving forward
All right.
to be near to the wall. And basically, yeah. And then here I'm setting a timer for the rotation, because controlling the rotation without a timer was also a bit hard, to be honest. It just did not align pretty perfectly. Like it was not aligning parallel to the wall.
Mm-hmm.
So I've thought of just adding a timer, and that worked. I've also had to like tune this and this, the duration of the rotation
Mm-hmm.
and the speed, the angular speed. And that's what worked the best at the end.
Mm-hmm.
And this is the end of my service server.
All right.
I can move on to the client server.
All right. While we're still on the server, right? You spoke
Yeah.
about the robot finding the wall, right? Does after finding the wall, for example, does it move towards it, or it just rotates 90 degrees from that wall? Because I seem to notice that on the run on the real robot, it seems to not go towards the wall to minimize that distance to 0.3 and then rotating whichever side, left or right, to follow it. Does that happen in that loop?
No, it would. Yeah, it's not in that loop. It's in this loop. It's here. I print out moving forward, and then here it moves forward
Okay, so it is.
until yeah, until you get almost 30 centimeters near
Okay.
close, and then it would rotate again
Okay.
to align with it. Yeah.
How did you choose 0.26, right? Was that just random or?
No, it was not random actually. I tried the 30 centimeters
Mm,
like it was required,
mm.
but whenever I would do the 30, it would actually be too close. Like it would be kind of out of the boundary. So when I made it less, I found 0.26 was kind of the perfect uh, number to get it still in the lane, but it's not very close to the wall.
Okay. That's mm, all right. All right. Let me take some time to think about that. But you can go on to the next script.
Okay. Okay, so now here I have my odometry recording action. This one is a bit it's not complicated, just long, I would say.
Mm-hmm.
So first of all, I'm using a class. I'm defining class here, and here is just I am initiating my required parameters for the action
Mm-hmm.
server. And here I am. Okay, I will also explain my error and that I faced in the action server creation,
Mm-hmm.
because in the beginning I would just take the start position and then I would um, like measure the distance until I get back to that start position. But of course, the robot almost never goes back to the exact same start position.
Yes.
So for that reason, I defined here two tolerance
Okay.
variables, one for the orientation and one for the position.
All right.
So if it's around that area with some tolerance of the start position, then it would consider that as a lap.
Uh-huh. That
And
was
after
good.
few runs, sorry?
That was good. That's actually how you're supposed to do it. So that was good.
I mean, I've also tried another approach of which also did not work, of just counting a lap after four big left turns, because
Oh.
the lab is like you turn left four times.
Uh-huh.
But that also did not work properly. Like it worked, but it wasn't optimal. So I
Mm-hmm.
found that just adding tolerance would be the optimal way to do it, to be
Mm-hmm.
honest.
Yeah, I wouldn't go for
So
that
that's
one.
what I did.
I wouldn't advise for that one as well. Because what if you tend to avoid an obstacle in a very sharp manner, right? Then that obstacle avoidance
Yeah,
will be
that's
yeah, will be considered a
yeah,
very
that's
big
kind
turn.
of what happened. That's kind of what happened. So I just thought that's not gonna work.
Mm-hmm.
And yeah, I went back to for initial logic just with tolerance.
Mm-hmm. Okay.
And then here, after a few runs, I've got also a minimum distance to check that, okay, if you did not um, pass this amount of distance, then you definitely did not finish a lab. And
Mm-hmm.
after a few runs, the lab is almost five, like each time it's about five. So I just set the minimum distance as five. So
Mm-hmm.
it
Okay.
needs to finish 5 meters and then it would consider it a lab.
All right.
And then here is just some parameters that I will use later. So here I have a function that cleans up after a goal, because it tends to be like a bit messy, because I will have a timer and I will have like an array and I will have many variables. So
Mm-hmm.
this is just cleaning up, a simple cleanup function.
Mm-hmm.
And then here is my main um, function, let's say. So here I have the goal and I clean it up. I clean up before even starting anything. Here I'm waiting for the odometry and I'm reading the odometry. And then here, so first I've tried to also just get the orientation as Z, as Z,
Mm-hmm.
like Z, but it did not work. So after a bit of research, I found that I could just use the earlier like angles to get the yaw,
Okay.
and it was easier to control. It was easier to like later on use it in calculating the distance. So I've just used like from the library here, I've imported transformation from the transformations library. I've imported earlier form function to
Mm-hmm.
just transform from the 2D orientation that I'm getting to IO or like theta, basically.
All right, all right.
And then here I'm just printing out the start position. Here I'm keeping track of the start position. Now I am reading the positions as I'm going on. This is just a simple, I've used a lot of try and accept because it's better at handling errors. So in case of an error, just prints out where is the error exactly. And then here I have a timer. If it did not, first of all, a timer for the readings. And here I have also a duration to call this the first function I've explained, because again that just worked better.
Okay, one more
And
minute,
yeah,
Rawan.
this is so okay, sorry.
All right.
And here I'm just cleaning up after the function again. This is just a simple timer I've set that also helps with keeping up the time. Time is very like very important in this action server. And then here I am just processing the messages, the odometry. I am calculating the distance using delta y, delta x, using the first position and the last position I read, and just printing out that distance. I am also getting the feedback. I am getting the distance, and I'm recording the last. I'm printing out the last end position I got,
All
and
right.
this is pretty much my records,
All
my
right.
action server. Sorry.
All right. All right. Thank you very much. Wonderful
You're
presentation.
welcome.
All
Thank
right.
you.
So we'll get into a couple of questions now. I would like to find out from you. So this is just
Mm,
general roster with Python stuff, right? So I want to know what is the purpose of
yeah.
the setup .py script. Can you explain to me its relevance to ROS2 Python ROSjects? I mean ROS2 Python ROSjects.
Sorry, can you repeat that?
The setup.py, right? You know, you do make
Yeah.
changes to that script when you compile Python code in in your ROS projects, right?
Yeah.
What is the purpose of that setup.py?
The setup dot py is I'm not very sure to be honest, but as I know that setup.py is just to set up the 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 environment for the ROS, and it sets up the essential parameters and the variables and what you would need to get the script working properly.
Okay, okay, all right. Yeah, you were very close to what it does. Actually, it's used for building the your project and also specifying the entry points, right? So how will your
Yeah,
executed ROS be executed? What interfaces are made available to ROS2 when you're calling? So you would say maybe ROS2
yeah,
launch a particular script, and then the entry points to that script will be specified in your setup.py, right? So yeah, you were close.
yeah.
And the other thing I wanna ask you about is the RCL.spin, right? Can you explain to me what the purpose of that one is with respect to running ROS nodes?
RCO or what? Can you repeat again?
RCLPy.spin, right? You know that function.
Uh,
You can open your, I think, any one of your either the action server or the client itself. Actually, let's see. So at the very bottom,
this, yeah. Oh, the spin one.
yes.
The spin is just basically makes the like it just helps it wait for so after it runs, it doesn't just close, it doesn't just end, it waits.
All
Like
right.
it makes the code wait, basically.
It keeps the node running. Yes.
Yeah,
Keeps the node running. All
yes,
right. One
yes,
final question. What is the difference
yeah.
between a service and an action? Can you explain that to me and
S-
try to
uh,
include um, reference to topics in general, right? So I want you to show me that you understand the difference between the three main communication modes you have got in ROS 2. So those are topics, actions, and services.
Okay. So the main difference between services and actions, that services are synchronous, as in like when they publish a topic, you need to they stop and wait for the response. When they publish a request, you need to stop and wait for the response. But actions actually, no, you can just you can publish it, you can let it do something while something else is running, like another topic is running.
Mm-hmm.
And actions and topics are pretty similar because they are both asynchronous, they are continuous, but topics are used for, let's say, small like, commands, let's say like a laser scan. It's a short term, and the actions, they're used for long continuous commands you would like to do, and it also has it also has a feedback and a result
Mm-hmm.
and cancel, which is does not exist in topics and services.
Mm-hmm.
So that's why it's mostly used for long runs, like reading the geometry, getting trajectory of the robot,
Mm-hmm.
and that's, I think, the
All right.
most
Yeah.
difference between them.
Those are the yes. Those are the biggest differences. Yeah. Um. So, all right. I think that's all in terms of questions from my end. So, very warm congratulations to you. It was a nice
Thank you
presentation.
very much. Thank
So
you very much.
I would say you hang around a little bit and we will wrap up here. Okay.
Okay.
All right, everyone. So this was Rawan's presentation, and warm congratulations to her. Would like to encourage all those of you who would like to try the courses we offer certification on to do so, and you can come and do your presentation to demonstrate your understanding. And other than that, we say keep pushing your ROS learning. Bye bye.